Yes. Thank you. So, yep. Trig Identities. Oh my goodness. Trig Identities. And if you were to ask your friends who have had this stuff, or your parents, if they even remember, they will all say, "Oh, I like Trig Identities." And there are some that like it too. In fact, periodically when I teach this, year after year, there are some kids that really like Trig Identities. So I always say, do you like to factor? If you're one of those kids that enjoyed factoring because it was a puzzle and you like to figure out how the puzzle worked, then you might like Trig Identities, okay? Because you have to think. That's the hard part about Trig Identities. You have to think. There's no set way to do it. You don't say do this, and this. You have to think and you have to look at your identity sheet. So let's first of all take a look. So when I do these, first of all, a hint is two. One, first of all, any kind of hint you want to try to make sine and cosine. If you make everything into a sine and cosine, then things will start to cancel and simplify, okay? And then the other thing I'd say as a hint is if you have any kind of a trig squared, like if it's a sine squared theta or a cosine squared theta, try and find your Pythagorean identities. What are your Pythagorean identities? That's these guys right here. These are your Pythagorean identities. So try and find a Pythagorean identity, okay? So let's take a look at number one. So it says simplify cosine plus tangent plus sine. Now the hint I said was try to make into sines and cosines, right? So I look at my identity sheet. I've already got a cosine and a sine, but what do I know about tangent? Well, tangent could be written as a sine over cosine. So if I rewrite tangent, completely change tangent into a sine over cosine, let's see what happens. So I'll have my original cosine squared theta, that's that one, plus, now let's change tangent. If I change tangent into a sine theta over a cosine theta times a sine theta, right? All right, you say, well, that didn't help me a whole lot, but maybe we can do more with that, all right? So then if oh, that's not a cosine squared. Sorry, forgive me, that's just a cosine. So from here, let's see what happens. I'll have a cosine theta plus a sine squared theta over a cosine theta, okay? Well, it doesn't look like much yet, but at least I've got things in terms of sines and cosines. Well, it's not really simplified a whole lot, but I do see a fraction. And whenever I add or subtract fractions, I need a common denominator, right? So if I look at this darn fraction, I think, okay, well, I need a common denominator. Well, this is sine squared over cosine, and this is cosine over 1. To get a common denominator, you've got to make the two bottom parts of the fractions the same. This one has a cosine, this one does not. So we're going to give it a cosine. We're going to multiply it by cosine over cosine to give it a common denominator, okay? So let's see what happens. If I multiply this by cosine theta over cosine theta. Hey, Mr. Johnson. Then what I'm going to get is a common denominator. I'll have a cosine theta on the bottom. That's my denominator, right? What I get on top is a cosine squared theta plus a sine squared theta, okay?
Wait, I still don't know what happened to the tan.
Great question. Take a look. Tangent, I go to my sheet. What is tangent?
Oh.
So I'm making a substitution. The identity for tangent is sine of cosine, so what I did, Simon, is I just rewrote, instead of tangent, I wrote sine over cosine.
Oh, okay.
Now, I've got, it looks worse. I mean, the whole thing I started with is something this little, and now it looks worse. But wait a minute. I've got a cosine squared and a sine squared. So if I get the squared thingies, I look to my Pythagorean identity. So let me check those out. And I know that sine squared plus cosine squared is equal to 1, isn't it? You see that? So instead of writing sine squared plus cosine squared, instead of writing cosine squared plus sine squared, I'm going to write 1. So then I get an answer of 1 over cosine theta. That's simplified quite a bit. But there's something more I can do. There you go. Exactly. 1 over cosine. 1 over cosine is secant. So all of this simplified all the way down to secant of theta. Nice job. That's exactly right. Yeah.
I have a question about the naming. So you know how they have sine and tangent? Well, how come they just didn't put cosine with secant like that?
Yeah, I know. I totally. Yeah, yeah. And you know what? A lot of this comes from other languages, and then eventually, as Americans, we wind up with. I think a lot of this came from like a German. I don't know. I do know that. Yeah. Well, we can't. We can't switch it. That'll really mess you up when you go to college. Okay, let's not switch it. Okay. All right. Example 2. Let's see if we can do example 2. Okay. So right at the bat, let's try and change things into sines and cosines. All right. So Simon, you asked a really good question. You said, what happened to the tangent? What do we know about tangent?
It's equal to sin over cos.
Not sin, because we're not in church. It's called sine, okay? So let's change tangent into sine theta over cosine theta, right? Times, what do we know about cosecant? Do you see anything about cosecant?
1 over sine.
Yeah, so cosecant is 1 over sine. So times 1 over sine. This is a pretty easy one, isn't it, compared to the first one?
Do they just cancel?
They cancel, right? Sine cancels sine. And you're left with 1 over cosine, which we saw up there, right? Saw right up there. So we can rewrite that as a secant theta, right? Right. Okay, example 3. You guys ready for example 3? These are tricky. You have to really search for the identities on your identity sheet to be able to do these. Now, right off the bat, first of all, before I do this one, there's definitely a trick. So, right, so they're not easy. So if I had, for instance, a cubed plus b squared a, all right? Let's go back to old-fashioned factoring. If I just, A's and B's, could you factor something?
Yes.
What would you factor?
A.
You'd common factor out an a, wouldn't you? Don't they both have an a? A squared plus b squared. Everybody agree with that?
Yeah.
So let's look at our problem. Let's do the same type of factoring. What do they have in common?
Cosine.
They have a cosine theta. So we're going to common factor out a cosine theta. And if I factor out a cosine theta, I'd have a cosine squared theta plus a sine squared theta. Now that's a square, which means it's probably a Pythagorean identity. Probably. So I look at my little identity sheet. Hey, there's sine squared plus cosine squared, which equals 1, right? So cosine squared plus sine squared is 1. So I'm going to go, okay, cosine theta times 1. That's easy. That's just cosine theta, right? That's just plain old cosine theta. All right?
Simon, how do you pronounce cosecant?
Okay. Should we turn the page? All right, now,
Is that the SC1?
example 4. So in example 4, let's change everything. Let's change, first of all, secant. I've got sines and cosines, but let's change secant. What is secant? Take a look at your little identity sheet. What is secant equal to? Yeah, so let's rewrite this as a 1 over cosine theta minus a cosine theta all over a sine theta, okay? Now, I actually made it worse, but hopefully with a little bit of work I can make it better. So, because I have a fraction within a fraction, okay? So, first of all, let's just take a look at the top part of this fraction. Let's just take a look at the top part. And let's take a look at how we can subtract these two. Again, like any fraction, you can only subtract fractions if you have a... You can't, because that's a minus, not a times, okay? Yeah. Yeah. An illustration of that might be if you had 1/7 minus 7. Right? You couldn't cross out the 7s, could you? Well, you could, but you wouldn't get the right answer. Okay. Anyway, so what we need is a common denominator. So the denominator here is cosine, right?
Cosine over cosine.
Yeah, cosine over cosine. So I'm going to multiply this one by cosine over cosine. Totally right. Let me get a different color. So let's multiply this by cosine theta over cosine theta. And let's see what we get. So I'm going to have then, on the very top part of this fraction, over 1 minus cosine squared theta over cosine theta over my sine. Okay, now I'll show you what I did, okay? So these two, in fact, I could even put it in red if that helps. These two now have a common denominator of cosine theta, okay?
Wait, wouldn't the denominator be cosine squared?
No. Great question. Glad you asked that. So if I had 2/7 plus 3/7, is the answer 5/14? Is the answer 5/14 49ths, or is the answer just 5/7, right? Right, good question. Right, so you'd only write it down just the one, right? Very good question. I'm glad you asked that, because a lot of kids will make that mistake. Thank you. That was a good question. So now, here's my denominator, cosine, right? And then I have a 1 minus cosine squared. You see the cosine squared, right? Now, I think I see something. I see a 1 minus cosine squared, and I think that's one of our identities. So I wrote it. I wrote the original Pythagorean identity in a couple of different forms. In fact, I even wrote it in this form right here, right? So if I look at 1 minus cosine squared, it is equal to the sine squared. See how that is? So I found 1 minus cosine squared is equal to a sine squared. So let's rewrite this as a sine squared. Okay, so we're going to rewrite 1 minus cosine squared. So I'm going to have a, let's see, put it up here, running out of room. So I'll have a sine squared theta over a cosine theta all over a sine theta. Okay, now let's go back to 6th grade math. If you have a fraction divided by a fraction, I'm going to make this a fraction, so number one. If you have a fraction divided by a fraction, what do you do? Multiply. Yeah, you invert and multiply. Remember that? So you invert and multiply. So let's rewrite this as a sine squared theta over cosine theta times we invert and multiply, right? 1 over sine theta, okay? So I just flipped this fraction. I just flipped it. Flip. So we invert and multiply. Remember that? 6th grade math, when we do fraction divided by fraction, we invert and multiply. Okay, so now what I can see is that one of these signs will cancel one of these signs, because you got a sine and a sine squared.
So sine divided by cosine.
Yeah, so I'll cancel a sine with a cosine, and then we'll wind up with, yes, I just heard it, sine theta over cosine theta, and I think that's an identity.
Let's call it cosine.
No, let's call it something else. Sine over, yes, let's call it tangent. Let's call it a tangent of theta. Again, look at your identity sheet. What is sine over cosine? Sine over cosine is tangent, right? So this original statement simplified all the way down to a tangent, okay? All right, example 5, last but not least, okay? Now, again, if you have a fraction, you're adding fractions, you need a common denominator, okay? So I'm going to have to multiply this first one by 1 plus sine. I'll have to multiply the second one by cosine, because my common denominator really is going to be this. My common denominator really is going to be a cosine times a 1 plus a sine theta. Okay, that's going to be my common denominator. So, well, what does this guy have? This guy doesn't. Cosine, what does this guy have? This guy doesn't. A 1 plus sine. So you have to multiply by both of them, and the common denominator will be this thing. So I'm going to go ahead and multiply this one by a cosine over a cosine, and I'll multiply this first fraction by a 1 plus a sine theta over a 1 plus a sine theta. Okay, now let's see what we get. So my common denominator, I'll put it down there. Here's my common denominator. It's going to be my, and I'll write it in red so you can see it, it's my 1 plus sine theta cosine theta. Okay, that's my common denominator. Okay, it's a little sloppy, sorry about that. That is a cosine, doesn't look like it. That's my common denominator. Multiply this one by 1 plus sine, this one by cosine. That's my common denominator. Now let's see what happens on top. So the numerator, the first one, we're going to have to FOIL it. We're going to actually have to FOIL this first one. I'm going to go 1 times 1 is 1. 1 times sine is a 1 sine theta. Sine of theta times 1 is another 1 sine theta. Sine times sine is a sine squared theta, okay, plus a cosine squared theta. Okay, let me give you a chance to catch up, all right? So I needed a common denominator. What I did was I multiplied this fraction by cosine of cosine. I multiplied this fraction by a 1 plus sine over 1 plus sine to get my common denominator. My common denominator is both of them, so it is a 1 plus sine over cosine. Now, I have to simplify the numerator. So I FOILed this. I got 1, I got a 1 sine, I got another 1 sine, I got a sine squared. I got a cosine times a cosine is a cosine squared. Now what a mess, right? What a mess. But I might see some things in here if I look carefully. Let's see, what can I do to simplify? Well, I can make that 2 sine, right? I can make that 2 sine. And I think that these two right here have an identity also, don't they? So for sure, I'm going to go 1, And like Nikolai said, I'm going to go 1 plus a 2 sine theta for sure. Totally right. Plus what? What is sine squared plus cosine squared? Well, let me check out what my little identity sheet says. Sine squared plus cosine squared is 1, right? So I'm going to rewrite, instead of sine squared plus cosine squared, I'm going to write 1, okay? Over my 1 plus sine theta cosine theta. Okay, how's that? Now, hopefully you can see something else. I'm really hoping you can see something very obvious.
What is it? You have to foil it?
What's 1 plus 1?
2.
Oh, gosh almighty. 1 plus 1 is 2, isn't it? So we can actually put the 1 and 1 together. So I have a 2 plus a 2 sine theta over a 1 plus a sine theta cosine theta. Okay? Anybody see anything else?
I do.
What do you see?
You can divide. Oh, the top is half the bottom.
Okay, so
the bottom's half the top.
So
on
let's.
one side.
You're totally correct. So if we common factor out a 2, what if we common factor out a 2 right here? Took out a 2, we'd have a 1 plus a sine theta on the top. Wouldn't we? If we took out the 2, right? Wouldn't we have that?
Yes.
Over our 1 plus sine theta cosine theta. Okay. Now they'd cancel, right? You can cancel. Yep. So then you're left with a 2 over a cosine theta, but that could be a 2 secant theta. How do you like that?
Secant theta divided by 2.
Right. Okay, now, here's our homework. I'm going to go ahead and push stop. I would really